Have you ever wondered what it would be like to build a car from the ground up? Students in Education for Employment classes know exactly what that's like. They designed and built an electric car as part of the Square One Educational Network's full-scale Innovative Vehicle Design Challenge.
At the very beginning, we started with a three-wheel recumbent bike, and we needed to make it longer to fit the person and all the equipment on the bike. First, we split the bike here and farther back there, and we welded this tube onto here to extend it. We also welded a mount here for the actual rack and pinion, which we are using to replace the original hand mechanism to turn it.
It's not just here's a car and here's how you wire it, it's the whole process through. It's the students designing parts and coming up with how we want to do it, and then what seems simple, like build sides on it, when all you have is three wheels and one bar going from front to back, figuring out how to do everything. So it's a different way of thinking, like about how to complete the whole project. Instead of one step, you have to think big picture, and if you do this, it's going to change that, and so on.
The students in EFE's mechanical drafting class designed parts of the car with AutoCAD. A local company helped them out with the fabrication.
Once we draw it out on the screen using various tools in the program, we have it plotted out over in the printers over there, and then we send that into the company.
Lucas Haley made the sprocket for the motor.
The sprocket's idea is when the motor turns, it will turn the back wheel for us. So it's like an automatic motor movement.
Once the designs are complete, the assembly work begins. James McNeese worked on the mount for the seat.
I had to drill 14 holes and tap them, which is basically putting out thread so that way we could actually mount the seat onto it.
Kids, they're coming up with some good ideas on what's going on. They're getting an idea of, hey, here's something that needs to be made. We need to get it right the first time. We need it to be done quickly because we need to get the prints out to the people that are helping us out. And so it's a good life experience for them.
EFE electronics and robotics students worked on the best way to power the car.
The students built a test station, and that allows us to provide different current to the batteries so we can see how the batteries perform over time. So they're trying to figure out the maximum performance of the batteries for what we want to do in this competition.
In May, 14 schools from across Michigan and one from Chicago met at the Michigan International Speedway to compete in the full-scale Innovative Vehicle Design Challenge. Sarah Westman drove the car for the Figure 8 course.
There were cones and at either side, and you'd have to loop through a little tunnel of cones, then you had to cross through some in the middle, and you just kept looping around. The track we were on, it was really broken, like the concrete was, so there were a lot of potholes. I think that's why our chain broke.
Cameron Andrews drove the car around the Ford Blue Oval track.
The idea was to do an endurance run to see how far we could go in an hour. We had a GPS that logged our top speed, our distance in miles, and our current speed. And we ended up getting pretty good. We only ran down the battery with the last few minutes remaining, so it worked out very well. We went a total of 11.5 miles, which is almost triple what we got last year.
Being a part of the EFE Square One team helps students with their time management and teamwork skills. They also had some challenges to overcome.
The front end of the car with the drive, it was backwards and reversed from what we had originally got with the kit. So trying to figure that out, and the rack and pinion, figuring how to reverse it, how to problem solve quickly in the time crunch, because we thought, it's simple, we'll leave it to the very end. And then that was the hardest part that we had to deal with on the car. So it was a lot of problem solving, new ways to figure things out, and quickly.
I think this is an excellent opportunity for the kids to get involved and to take what they're learning in the classroom and apply it in the real world.
They've done the drawings and they know how to put stuff together. They've seen it in animation. They've done all that work. Now they can actually apply it to something that they can physically see, and they can see it going around the building. They can see it driving outside.
I'm thinking of going into engineering and being able to work on a team, working with other groups as well, like the robotics class, and just getting a feel for the whole process of actually constructing our own project of this scale was, I think, a really good experience.
I love the hands-on work. I like to just be actually working on something, being able to see that finished product.
And to give them a good head start if they want to enter this career in these areas.
The Education for Employment team placed third in the Oval Performance course. They hope to compete again next year.